Year two then, just starting off with a respiration question. When we're reading questions like this, it's really important to note what type of respiration is being completed. So it tells us that it's aerobic respiration, and then we've got a woodlice doing it. So you'd put a little woodlice into it. The woodlice will be respiring, so therefore it will be taking in oxygen, and theoretically it will be giving out CO2. But it tells us in this case there is a substance called soda lime that is going to be absorbing that CO2. So the CO2 is going to make its way. So overall, the pressure within this glass tube is going to go down. And if the pressure in the tube goes down, means the liquid that's in the piece of equipment will be drawn towards it. Some key information from the diagram. It tells us the diameter of the capillary tube that's used is 2.5 mil. We've got a ruler with a scale, an unusual addition to this, so it might suggest that we want to use it. And in fact, we can actually use it to see how far the liquid has actually moved. So if it starts at this point and it moves to this point, we can say it's gone 1, 2, 2.5, no, 225 even millimeters, that it's actually moved the coloured drop, assuming that it started at the beginning of the tube. And we've also, clearly on the diagram, got a three-way tap that's labelled and a syringe. Don't forget, a lot of these pieces of information are there for a reason. The examiner doesn't waste ink. He wants you to use it if it's there on the screen, on the page. So we're thinking the fact that the student altered the temperature, so that's the thing that they are changing, and they changed the temperature of the water bath, and they were seeing how far the colour drop moves every 5 minutes. Other than those stated, so just two variables that the student should have kept constant. So a lot of you are writing temperature. I really don't know why, because it's clearly telling you that temperature is altered. It's like you didn't read the question properly to be able to answer that. We can have things like the volume or mass of the soda lime, the concentration of the soda lime, the number or mass of the woodlice. We're accepting the weight or the volume of the woodlice as well. We've got the age of the woodlice, we've got the same woodlice, we've got the species of woodlice, we've got the time the woodlice acclimatized to the temperature. A few of you were writing this one about thinking about the concentration of oxygen inside the apparatus before you're actually doing it, and light intensity, because you don't want light intensity to somehow affect what's going on. If the woodlice is in a bright light, is it going to respire more and therefore be a variable that's affecting your results? Just as a other thing to think about, that we've got the amount or concentration, we don't accept amount for concentration, volume, weight or mass. We've got to get away from using the word amount. It is far too vague for our A-level answers. Question point 2, describe how the student used the apparatus in figure 1 to reset the coloured liquid. So it's a describe question. Physically tell me what you are going to do. And it says you're using figure 1. How am I going to move the coloured liquid back to the right hand side? If you look at the diagram again, there's only two pieces of equipment that you're going to need to do this. And a lot of people were mentioning pressing the syringe. But quite a lot of you didn't think about the tap. You've got to make sure the tap is open, then you press the syringe and it will push air into the equipment and allow the coloured liquid to move back to the right. The student also set up a control experiment. Suggest a suitable control and explain why it was necessary. So I want to tell the effect of respiration from these woodlice. So my control means that I'm not going to put my woodlice in there. Everything else should be the same. Why do I want to do this? Because I want to prove that respiration is occurring from the woodlice. Yes, you're changing the temperature, but I'm seeing the effect of temperature on respiration. So therefore, put no wood lice in, or put some glass beads instead. You could even say a dead wood lice, but everything else needs to be the same. The reason that we want to do this, and the explanation for point 2, is to show that wood lice are causing the drop to move, wood lice are taking up oxygen, wood lice are causing the change in temperature, not simply wood lice are causing respiration. That's not what our experiment is physically showing us. It's what the results mean, but it's not the actual results you take away. Finally, we've got a maths question. We've got quite a few juicy maths questions in this paper. You'll notice that AQA like to make them 3 marks now in the more recent papers, which for me I think is more justified. It tells us that we're working at 25 degrees. The wood lice was 3.79 grams, which is going to be an important piece of information potentially. And we've got use figure 1 and figure 2. So we're using the actual diagram of the equipment. I want to know the mean rate of oxygen uptake by the wood louse in millimeters cubed per second per gram. The formula for the capillary tube is pi r squared by L, and then the pi is 3.14. Loads of information to actually process here. So the first thing is I need to know how much the drop of liquid is actually moved. Now in the previous bit, I did say you could use the ruler and determine that the liquid had moved 25 millimeters. Same principle over here. It tells us that we did the experiment for 5 minutes. So if I went to 5 minutes on my graph, I could read off the same idea that the distance that the coloured liquid moved was also 25 millimeters. So the fact that the distance is 25 millimeters, that's our L. That's the length that the actual liquid has moved. So if I focus first of all on working out the volume of the capillary tube, then I'm going to do 3.14, which is my pi, times by my radius, which is half my diameter, so 1.25. And again, where did I get that information from? Well, in figure 1, it tells me the diameter is 2.5 millimeters. The radius is half of that, so I've halved 2.5 to get 1.25, and I've got to square that, and I'm going to times it by the distance or the length the coloured liquid has actually moved, which is 25. So therefore, the volume of the capillary tube in relation to this experiment is 122.67. But that is not per second, and that is not per gram. This is actually the millimeter cube per 5 minutes per 3.78 grams of wood lice. And I need to make it per second. So first job, if I think about time, well, at 5 minutes, I'm going to times by 60 to put it into seconds. So that's actually 300 seconds. So my first job is I can do 122.67 divided by 300 to give me an answer of 0.4089, but that's still not per single gram. So then I still have to do one more calculation of dividing it by 3.78 to make it per gram, and it gives me an answer of 0.108, which is correct. However, the question says that it wants 2 decimal places. Please go back and have a look at all the maths questions. Every single maths question has got some weird caveat to it, as in like it's three significant figures or 2 decimal places. So in this case, it's 2 decimal places. So therefore, my answer should be 0.11 to be able to get 3 whole marks. Let's rub out all of this. There we go. Lots of different variations of making it 1 mark or 2 marks. Makes the maths questions a little bit more trickier to mark. Now they're worth 3 marks overall. So just be careful, look at your answer, see if you would have got a mark or 2. And if not, think about the workings that we've just been through.